All right, guys, welcome back. Today we're going to talk about points, lines, and planes. Let me just grab my teacher notes here. And it's Spirit Week, so today's Inside Out Day, so my clothes are inside now. That's why it looks a little weird right now. Okay. But anyway, our first official lesson, which is exciting, in geometry. So points, lines, and planes. These are the basic building blocks that help us create the shapes that we look at today. So let's get started. A lot of definitions and notes. We're going to try and go through this as quickly as possible, but please pause the video. So subway map. So a pre-question would be, how is a subway map related to geometry? What could we see in this map that we could say, hey, that's part of geometry? Okay, so feel free to write down some things, and then after the lesson, compare what you learned. Definition. What does a definition mean? It's a statement that defines a mathematical object. Okay, so if you ever heard the word definition in mathematics, that's what it means. Now, an undefined term is a basic mathematical term that is not defined by using other mathematical terms. Say that 10 times fast. All right? That just means I cannot describe this word with other math terms. Okay, so a point, a plane, and a line, those three, which is the title of today's lesson, are considered undefined terms. We know what they are, we can describe them, but we don't have other math terms to do that. Okay? So anytime you hear people shout out, what are the undefined terms in mathematics or in geometry? It's points, lines, and planes. Okay? So how do you define a point? Okay, well, it names a location and has no size. That's important. Just because on a map, one location has a bigger point and this one has a smaller point, that doesn't matter. It doesn't mean anything, okay? It just means that they just made this a little bit more emphasized, okay? In the coordinate plane, we know that a point is represented by an x and y coordinate. So here's some examples of points, just naming something point A by an x or y or by location. A space is a set of all points in three dimensions. And in order to locate a point in space, three coordinates are needed, so x, y, and z. If you ever get a chance, maybe in this class we'll talk about three-dimensional coordinate system, your x, your y-axis, and your z, the height, right? That's what z is. The z-axis gives you height. So to define a space, you need a little bit of a height. So just like in this classroom, I'm going to define the space in this classroom. I cannot define it by just the floor and the walls, okay? I need more than that. Let me clarify. I can't just define the space by just the floor. I need the walls and everything else. I need the height, okay? So I need 3 points, x, y, and z coordinate, okay? A line. It's a straight path, has no thickness, and extends forever. There are an infinite number of points on a line. When it says has no thickness, it's just like a point. It doesn't matter if one of the lines on my grid is larger or smaller. Okay, that doesn't indicate anything different about it. So same thing here. It's just a representation of something. Okay? When we name a line, we can pick 2 points that are on it, any 2 points we like. So I picked A, B, and we put the line symbol above it. This is where I'm going to be very picky on how you name things. Okay? This is a transition from computing to labeling. Okay? The first lesson of geometry is very heavy on labeling. And just like in any foreign language, you got to make sure you write the language correctly, right? Same thing here. In geometry, you got to make sure that we write things correctly. So you pick any 2 points. I could have named this BC or line CA. Order doesn't matter. With the line symbol above it. Or what I could do is I could say the word line and use the letter that's next to it. Now notice, see how X doesn't have a point? It's just there hanging out. So I could call this line X. Okay? If I do that, it has to be lowercase. So if I name it by one letter, it has to be lowercase. If I name it by 2 points, make sure they're uppercase, okay, with the line symbol above it. Some people I've seen people say line AB, you put the line before it, they actually write the word. You can do that. That's no big deal. But make sure when you're naming a line, you're using proper notation. Okay? Points, different categories. We could have collinear points. It's the set of points that are on the same line. They're all together, so we call them collinear. Imagine that. The word matches the definition, right? Okay. Linear means line. Co is just like cooperative in a way, right? That might be a stretch, but still, you can kind of get that together. Non-collinear is the opposite. We're naming a group of points that are not in the same location, not in the same line. Okay? Let's do an example. Example 1. And once again, I am going a little bit faster because you can pause the video. What points are considered collinear here? So we want points that are on the same line. So we could say what? Points A and B, they're collinear. We can do B and C. We can name all 3 of them. Okay. A, B, and C. They're all collinear. They're on the same location. What points are considered non-collinear? Now, a lot of people say, oh, that's point D. Okay. You need to partner up with someone. Okay. I can't just say point A and just say, okay, that's it. Well, we need some reference to it, right? So what are we going to do? Well, we could say, for the next question, A and D would be non-collinear, right? They're not in the same line. We could say B and D. We could write all 4 of them, right? They're all 4 not in the same line. So that's another thing that we could do. Now, some people might argue, can I just draw a line to make it collinear? You could, but just for the sake of this example, I'm just trying to show you that there's a separation here. I don't want to get too muddled into the details right now, okay? So all 4 of them would be considered non-collinear. So multiple answers for both of them. Another example, okay? And once again, write this down in your notes and try it out. Give 2 different names for the line. Well, we could name it with 2 points. So I can call this CD, put the line symbol above it. That's one way I can name it. The other way is I can name it with the letter that's just out here and just hanging out. All right? It's just chilling. So it could be line Y. Remember, that's going to be lowercase if you use those. Okay? So you can pick 2 points with the line symbol above it, or do something like this. So those are 2 possible names. I could have named this DC instead. I could have flipped them. I could name it DF or FC. But just be cautious. You just want to pick 2 points. You don't want to say this is line CDF. Okay, just pick 2 points. That's all you need. Name 3 collinear points. Well, there's only 3 of them on there, right? It would be C, D, and F. They're all on the same line. 3 non-collinear points. Well, it's any combination of these points, making sure you include E. So you could say C, D, and E. Those would be non-collinear. They're not on the same line. You could say D, F with E. As long as E is in that list of 3 of them, you have non-collinear points. Okay? Any questions, thoughts, concerns, dilemmas? No? You guys are quiet now. I know, bad jokes. I try. Trying to make the video interesting on this. Okay, the last object is a plane. A plane is a flat surface, has no thickness, and extends forever. Okay? It's pretty much defining an area of something. Okay? This classroom floor is like a plane. It goes on forever, has no thickness. If you're just talking about it at a concept, an idea of sorts. But some of you might say, well, Mr. McCullough, it doesn't go on forever. True. We do have borders up, right? So we're defining the plane a little bit more. So when you look at this picture, people say, well, if it extends forever, why do I have it as a square? Well, I'm just defining the plane. I'm saying this area is my plane. Okay, it's just giving me a location for right now of what I'm looking at. Okay, a plane is named using either an uppercase or 3 uppercase letter, or 3 non-collinear points. Now, here's where they're using some vocab we just learned. So the uppercase letter is just like the line. You see how this letter is just hanging out? There's no point next to it. So I could name it that way. And I did that here, plane P. Or use the 3 points that are non-collinear. Meaning, can I connect a line with these 3 points? No. So they're non-collinear. So I could call this plane ABC. I honestly, to be honest with you, personally, I think it's a good practice. Don't just put ABC, put plane before it. Okay, be specific. The more specific you are with these, the better it's going to be for you to interpret and understand your work in the future, and helps the teacher out too. See, it's a good thing. Okay. Now, the order doesn't matter. I could have called this plane BAC or CBA. I just want to make that clear. Here's a good question. Why 3 points? Is that some sort of arbitrary number? Might be. Think of it this way. If I named it with 2 points, what am I truly naming here? Naming a line. Any 2 points I name, I can connect with the line. But I don't want a line. I want more of a space here. I want more of a area. So I need 3 points at least to create that. Does that make sense? Okay. So I can't just use 2. Mathematicians come up with an answer saying, oh, we need at least 3. Why is that? I don't know. They have a reason. It makes sense, really. 2 points, names a line, no matter what. If I put a point on that whiteboard over there or on this whiteboard over here, I can still connect it with the line. Doesn't give me a plane yet. You need 3. Coplanar, non-coplanar. These are adjectives, just like the other ones. Coplanar means all the lines and points are in the same plane. They're in the same area. Okay? So think of it as like a sheet of paper. Here's my plane, okay? And my lines and points that are in this plane are coplanar. Non-coplanar is the opposite. So let's say I had lines and points in this plane. They're going to be non-coplanar to the ones that are in this plane. They're in different areas, different spaces. Okay? One final note when it comes to planes, they don't have to be squares. You could have planes that are triangle shaped. Okay? You could have planes that are weird looking polygons that are non-convex. Okay? That can happen. Okay, planes don't always have to be squares or rectangles. It's just very common to see it that way. Okay? Example. What are 2 different names for this plane? Let me just put a quick plug in. You see this line? The dotted line part. Okay, zoom in if you can't see it. The part that's dotted is the line going behind the plane. You technically can't see it. So for instance, my line hit the plane at a point, okay? That's what happened. So this direction hits the plane, goes through it. You can't see it for a little bit, and then it comes out here at the bottom when you can't see it. Okay, that's what the dotted line means. So 2 different names. Well, the first is plane M. Okay, I can just go ahead and use plane M. Just a letter. It's not a point. Okay, I want to be very clear on that. A lot of people get that confused. When the letter is out there and there's no symbol next to it, it's not a point. It's only there to name it, to name the plane or the line. If we go back to that example, just be careful on that. What's the other name? I can't talk. What's the other way to name it? Use the 3 points. Okay, 3 non-collinear points. You cannot connect F, G, and H, so you could call it plane GFH. Any way of scrambling that. You cannot include I. I is on the line, but it's not on the plane. Okay? Next one. Identify 2 coplanar and non-coplanar lines in the diagram. Once again, you see how line T is intersecting the plane? So this dotted part means line T is going behind the plane, and it comes out here at the bottom. Okay? So coplanar lines. What would be the coplanar lines? Well, it's going to be lines, line M and line N. It's like all squished together. Sorry about that. There we go. They're coplanar. See how they're laying on the plane physically? They're in the same plane. Okay, non-coplanar. Now some people, this is where it could get a little confusing. If you're intersecting a plane, you're technically not coplanar to it, okay? So if I had this marker and it went right through my plane, it's not coplanar to this, okay? To be coplanar, you have to be laying on the plane. So for non-coplanar, you have a lot of options. You can do line M and line T. T is the intersecting one, so those are non-coplanar. You can switch it. Okay, put line M in there, or put all three. All three of these do not lie on the same plane. So all of these are possible answers for non-coplanar. Remember, that W is not a point. It's only there to name the plane. Okay, intersection. The intersection is just the point where two figures meet. So for the first one, the intersection of two lines is a point. I think that's very simple. I think we know that. I hope we know that. The intersection of two planes is a little bit different. If I intersect these two pieces of paper, let's say these are my two planes, okay? And I intersect them like this. What can I draw at the intersection? Do you see it? I can draw a line. The intersection of two planes is a line. Okay? You see that right here? That's what this image is showing. So if I intersect a horizontal and vertical, I get a line. Or any angle. But no matter what, if those two planes intersect, they intersect at a line. Okay? Example. What's the intersection of line AB and CD? Notice they use the proper labeling. You should do that as well. Remember, I'm going to be a little bit picky when it comes to that. Answer is point E. Okay? Point E is the intersection. You don't have to draw this. If you can draw this, that's excellent. Okay? Even I have trouble drawing intersection of planes. It's not an easy thing. I wish it was, but at least for me, it's not that. It's just, I don't know why. It just seems weird when I draw it. What's the intersection of line AB and CD? Is the first question. Go back to what we just stated. When the lines intersect, it's a point. So I'm looking for a point. So here's line AB, here's line CD, intersect at this point, so it's point E. That's the answer for that guy. So point E. I'll abbreviate that. And the intersection of plane P and Q, think about what that answer is ahead of time. The intersection of two planes is a line, so I'm going to name a line, and that's going to be right here where they intersect. So it's going to be line AB. There we go. Those are the 2 points I'd pick. Okay. Could you include E? Yeah, absolutely. Could have said EB or BE. Doesn't matter the order on that. Okay. All right. So just a couple of random multiple choice questions, and please pause the video so you can answer them. You don't have to put these in your notes. It's just kind of like a final thing. Line BN and XO, where do they intersect at? Well, if you take a look, BN is here, XO is here, they intersect at point R. C would be the correct answer for that guy. Next one, are the points X, O, and R coplanar? Coplanar means that they have to be in the same plane. X, O, and R, are they all in plane T? Yeah, they are. So the answer is yes. Name 3 points that are collinear. Well, take a look at the picture. Collinear means they got to be on the same line. B, O, and X. B, O, and X. They're not the same line. X, O, and N. X, O, and N's down here. They're not in the same line. Rob, R-O-B. Nope, they're not in the same line either. A, X, and Z. A, X, and Z. Yep, D. D would be the collinear points. They reside on the same line. So to wrap it up for us, go back to the subway map at the very beginning of the lesson. Can you now pick out some things? Think of lines, points, planes. Could you relate that to a subway map now? And you should. Okay. Some of these are not lines per se. Yeah, they got some arcs and curves to it, but there are some straightaways. So you could say that this represents a line, these two parts of the transportation route. The whole mapping itself, the whole map of the subway could be a plane itself, right? Okay. The intersection are different points that the two rails meet. Okay. So that's another thing you could talk about. But this is kind of incorporating the theoretical to the application in a way. You know, I think a lot of times in a math classroom we always talk about finding X or label this or define that. But how does it look in the real world? So this is like one example. Okay, subway map does show some geometry there. Okay? Hope everything's going well, guys. I really do. First lesson down. All right, we got into geometry finally. We're out of probability. So if you have any questions, feel free to email. Other than that, have a good day.